Grid codes, actually this is a significant subject related to renewable energy source must be understand what means. Grid codes, actually 2 points very important related to the grid codes. Grid code is created to satisfy the requirements that renewable energy source must be able to handle voltage drops of a certain percentage of the rated voltage. In some cases, 0% of the rated voltage. Of course, for a certain amount of the time. This is one. Two, also, reactive current injection is proportional to voltage drops to improve the voltage stability. The grid codes are very different from one country to another. Actually, according to my research, Germany, Italian, Australian grid codes are more stringent, which require renewable energy source to stay connected even through voltage drops to zero. So we will talk about the German grid codes. This figure depicts a German grid codes for the fault ride-through curve for a medium voltage renewable energy source linked to a grid system. Because of these requirements, the renewable energy source must remain linked to the grid if the voltage at point of common coupling drops to the zero. When the voltage will be see it drops to the zero, must be renewable energy source connected, stay connected to the grid system. We see for a period less than 150 millisecond. And if the voltage will be the voltage falls to the area B, as we see here, the renewable energy source will disconnect from the grid. Now, the another figure, this figure shows the requirements for dynamic reactive current supports. We see it's required that renewable energy source support the grid voltage by supplying more reactive current when the voltage drops LVC, and actually when the voltage decreases, drops more than 50%, the converter must be inject reactive current 100%, and of course depends on the converter designs. On other types and some types more than 100% inject reactive current, and when the voltage increases, of course less reactive current inject to the grid system.